Okay, everybody, I hope it's going okay. Monday, April 13th. Only thing new I'm adding today is we're still solving equations with a variable, an x squared equations. But the only difference is today, instead of having everything on one side, 0 on the other, which step 1 says get every term on one side. Last Friday, everything was on one side. Today, not everything's going to be on one side. And we'll just do 4 quick examples to show you what to do when in that situation. Okay, first, this was like last Friday's. Step 1, when you see an n squared equation, try to get everything on one side. The difference here, again, from last Friday is when you have an n squared and an n, you cannot combine like terms and get this down to one term. So you can't solve it like you have in the past. What you do instead is you get everything on one side, 0 on the other. Then try to factor using one of our methods. This is a trinomial. So I'm going to factor this using what I call the math game. What multiplies to get 24 but adds to 2. My options are 2 and 12, 1 and 24, 3 and 8, and 4 and 6. It's 4 and 6. To get a negative 2, the 6 has to be negative. So I factor this into n minus 6, n plus 4 equals 0. And now, after I factor, I set each factor equal to 0 and solve. And remember the concept here, I'll write it over here to the side. I don't care what add and subtracts to 0, but when I change it to a multiplication problem, which is what factoring does, this changes it to a multiplication problem. I know that the only way I can multiply to get 0 is if either one of these guys is 0. So what you do is you find out what does it take for n minus 6 to equal 0. What does it take for n plus 4 to equal 0? Well, for this one, n would have to be positive 6 because 6 minus 6 is 0. And over here, n would have to be negative 4. Okay. Reminder again, when you have a squared, you typically have 2 answers. In this case, 6 and negative 4. That was last Friday, where everything was already on one side. Problem 2, if everything's not on one side, you need to move everything to one side. Now, what I also mentioned in the notes, I'll open this up for you to see it. What I also mentioned in the notes is keep the squared term positive. Since k squared is positive, I want to move things to the k squared side and also write everything in order. Write things in order, k squared, k, and then the number. Okay? So I'm going to move the negative 42 to the other side. The way you move the negative 42 to the other side is by adding 42 to both sides. When I add 42 to both sides, there are no like terms over here, so I just write it in order. K squared minus 13k plus 42 equals 0. So let's move the negative 42 to the other side, make it a positive 42. There are no like terms to join up, so I just write plus 42. Again, write it in order. K squared, k, number. And now we try to factor it, just like Friday's assignment. What multiplies, it's a trinomial. There's no GCF. It's a trinomial, so I think what multiplies to 42 but adds to 13? It's 7 and 6. To get a negative 13 and a positive 42, they're both negative. So this factors into k minus 7, k minus 6 equals 0. And now that I have a multiplication problem of something times something, I find out what does it take for k minus 7 to equal 0? Positive 7. What does it take for k minus 6 to equal 0? And it's positive 6. Remember to go back and substitute if you're interested to make sure it's right. I could put a positive 7 right there, which gives me 49. I could put a positive 7 right there, which gives me negative, I believe that's 91. And when I take a positive 49 and negative 40 or negative 91, I do come up with negative 42. Positive 7 does check. And the same thing, you could plug in 6 and check it as well. Yep. A slightly different one. I have a p squared and a p. There's no way to combine this and get one p term to solve like you did in 6th, 7th, and 8th grade. So instead, I move everything to one side. Since p squared is already positive, I want to move stuff to its side. P squared minus 7p. I want to subtract 7p from both sides. They're not like terms, so I can't join them up. And I gave you this one because when you factored, I just wanted to remind you there were some questions about this Friday. This is a GCF type. They both share a p. So I can pull a p out. And then I have a multiplication problem. It's a distributive property instead of two FOILs or two binomials. And I set this one equal to 0, which gives me an answer of 0. And I find out what does it take for this one to be 0, which is positive 7. This is a really easy one to check. If I put a 0 there and a 0 there, obviously both sides are going to equal 0. And positive 7, if I put a positive 7 there, I get 49. If I put a positive 7 there, I also get 49. Like I said, a very easy one to check. And then the last example is a little bit bigger. Okay, let's analyze this problem first. There's the equal sign. Okay, I have an r squared and an r, so I can't get everything to one term. So I want to make sure I get everything to one side, 0 to the other. I want to keep the r squared positive, so I'm going to move both of these guys to the left. The way I move an r is by adding r, and I'm going to add it to its like term. And I want to subtract the 5 from both sides to its like term. That cancels the r's, that cancels the 5, and my goal was getting 0 on that side. And now I need to combine like terms over here. There was nothing to combine the r squared with. A negative 2r and a positive 1r is negative 1r. A negative 37 and a negative 5 is a negative 42. Okay, so to move everything to one side, I plus r, and I minus 5. Now, it's just like Friday's assignment. There is no GCF. It's a trinomial, so it's what I call the math game. What multiplies to get 42, 7 and 6. I need a negative 1 when I add or subtract. So the 7 has to be the negative. That's the game. Positive 6, negative 7. So my factoring is r plus 6, r minus 7. And then now, because I have a multiplication problem that has to equal 0, either one of these guys can be 0. So I find out that this one needs to be negative 6 to get 0. And this one needs to be positive 7 to get 0. Okay? Reminder, make sure you're showing steps. I am not going to accept answers only. I realize there are math apps out there that can give you an answer only. When I say show work, I want to see that equation. I want to see the factored step. And I want to see the answer. Most of you could probably see how to get positive 7 and positive 6 there. But I want to see those 3 steps. In this problem, I want to see what you did to get everything on one side. I want to see the factored step. And I want to see the final answer. Not just the final answer. Okay? If you have any questions, let me know. I'll get this downloaded quickly and hopefully you can get it up and running. Have a great day.